Hi, everyone. Welcome to Foresight's Space Group, chaired by Kriya and David. Very, very, very excited to see many of you here. We've had a few really fantastic talks in the past few months, and we're already working on next year's program. This is, for me, a reminder to all of you guys to use the nomination sheet that's now attached to every email to nominate other folks. You can self-nominate to give a talk, and we'll, in the back end, try to make sure that everyone kind of circles through because ultimately, like, I think everyone who's in these calls should really be presented in these calls. Okay, so two things on my end before we get going. I just want to make you aware of two opportunities. One is we now have the space group since this year, and it's coming with a fellowship starting next year. And so if you want to apply, we've already had a few folks apply from this group. Then I just want to make you aware that the fellowship applications are open. They're from our website. There's a banner, but I'm also going to share them here again in the chat. Second thing coming up, whether you're in Europe or San Francisco, we have Vision Weekends coming up. Vision Weekends is our annual member gathering where the kind of like top folks from all of our different technology programs are meeting. And here we have our different tracks. You're obviously in this track here. We have a few really great folks joining. Many of them are on this call already. But it's going to be in the US and in France. So wherever you are, you're welcome to join. I would encourage you to click on the individual buttons, check out who's there. There's an application form there for you guys to apply. And that's usually, I think, a nice way for us to all meet in person and to kind of reminisce on the year and plan for the next one. Okay, that's all for me. I'm really, really excited to see Kieran and Eric here. And yeah, I'll be in the chat. I'll be sharing more bios. And Kieran, I'll pass it on to you.
All right, great. Thanks, Allison. Yeah, I want to encourage everyone to attend Division Weekend. It's awesome. It's like one of the most amazing conferences there is. We're fortunate enough to have Eric Salwan from Firefly presenting to us today. He's got a lot of interesting information. Some of it probably not very publicly known. I've known Eric. I guess I met him. It's funny. I met him both socially and through business around the same time. And I try and drop in on him in Austin whenever I go. And anyway, Eric is going to tell us the story of Firefly past, present, and future. And then we're going to start some interviews and questions. So let's just get to it. How about it, Eric?
Sure. Great being here. Thanks for the intro. There's, I think, a couple people on here that I know, others that I don't. My name is Eric Salwan. I am one of the co-founders of Firefly Aerospace. I was one of the seed investors in Firefly Space Systems, which was the predecessor company. Started in 2014. It's now 2022, sort of towards the end of 2022. So we've been at this for a while. If you guys are familiar with the story of Firefly, we actually ran out of money in 2016 and we shut down and then restarted in 2017 as Firefly Aerospace. It's been quite the adventure. I'm going to give you guys, and I think a lot of the people here potentially know about the space industry. So I'm going to share my screen, do a quick overview of Firefly, and then we'll just get into a conversation with Creon and with the rest of the folks that are online. So is everybody able to see my screen?
Yep.
Okay. So Firefly is a space transportation company. And what that means to us is that we're building launch vehicles, the first one being Firefly Alpha, that can take satellite spacecraft from the surface of the Earth into orbit. And then we are going to build spacecraft, such as the Space Utility Vehicle, which is an in-space vehicle that can then fly things around in space and do other missions that we'll talk about. And finally, we're building a lunar lander called Blue Ghost, and that will give us the ability to land on other planetary bodies. And we'll talk about that a little bit too. So the first thing that we started doing is Alpha, which is a 1,000 kilogram to LEO launch vehicle. It's the largest all composite rocket that's ever been built. We did the first launch of it September 2nd, 2021 in Vandenberg Space Force Base. And it didn't get to orbit, but it was about the most successful first launch for a rocket this size that's ever been done. We had a small electrical system issue that caused one of the engines to shut down about 12 seconds into the launch. And this rocket is not built to be able to survive if one engine is out, but it's still got 2.5 minutes of flight time. We got a lot of great data, and we're now getting ready for flight 2. So I'm going to have a video. I'm going to play this short video that really shows a lot about what we've done at Firefly. Creon, if the video doesn't play correctly, just give me a thumbs down and I'll take it off, but I think it hopefully will be okay.
There's no audio. That matters.
Oh. So are you guys not getting audio?
No audio.
No, there's audio. It's just really turned down.
How's that? Any better? Can you guys turn your audio up? I don't know. Let's see. I'm going to start it again and you guys let me know what happens.
I think we're low audio.
Okay.
Okay.
First flight is a huge milestone for a rocket company. 3, 2, 1. But ultimately, this business is about getting to it. We did learn a lot from the first flight. As far as the vehicle goes, we're almost there. In one sense, first flight, we fixed the minor problems with the flight vehicle. What has impressed me most is the growth of the team. The first flight vehicle, it took us over 18 testing to get it. And for the second flight, both the vehicle and the team, all of us in the first attempt, we were able to qualify the vehicle in only one test. Firefly is excited about taking the company to the next level. Got smarter, faster, and more disciplined. We are ready. See you at the launch pad.
All right. We couldn't really hear the audio, but I mean, it was beautiful.
Yeah. Okay. Sorry about that, guys. I'm not sure if that was a Zoom issue or what, but in general, we're getting ready for the second launch. The vehicle is at Vandenberg right now. The launch is scheduled for September 11th. We have a backup date of September 12th, and we're feeling pretty good about this rocket. You know, this is, people joke and they say something is rocket science, but it's actually really tough because one system failure can take down the entire vehicle, which is what we saw in the first launch. This one has been checked out very well. Much better build than the one previous, and that's because the team is just more experienced now, and we're excited about it. So just some quick things about Firefly. All carbon composite rocket, largest one in the world that's ever been built. We're using in-house propulsion. It's called tap-off cycle. So if you're familiar with rocket propulsion, typically an engine has a gas generator that spins a turbo pump. This doesn't use a gas generator. It actually bleeds off combustion gases from the main propulsion to spin the turbo pump, and that results in a simpler, less expensive, more reliable rocket engine. And this is the first tap-off cycle engine that's ever been attempted to be flown orbitally. We're using AFP in the future, so that's auto fiber placement. And that's like a giant robotic 3D composite sprinter. Right now, it takes us about 3 months to build all the structures for the Alpha. With that AFP machine, we're going to be able to get that down to about 3.5 days. So that's really going to unlock our ability to move fast and to do a lot of future Alpha rockets.
Eric,
Yep.
do you have any video of that machine in operation?
I don't, not that I could share right now. Yeah, so we actually have the machine built, and we're building a building in Texas to move the machine in, and hopefully towards the beginning of next year, we're actually going to start using it. We haven't started using it yet. Right now, we're still doing the hand layup. So we have our main facilities in Cedar Park, Texas. We have a 200-acre test site about 30 minutes north. In Lompoc, we have our Vandenberg launch site, and then we're going to build another launch site in Cape Canaveral. Great team, a lot of space industry veterans, and we're continually expanding the team. Tom Markusic was the founder. He was the original CEO of Firefly. We've recently gone through a pretty intense process called with the Committee of Foreign Investment in the U.S. called CFIUS. As part of that, we replaced our main investor that put the first $200 million into the company with A Industrial Partners. And we're bringing in a new CEO that should be starting here the beginning of next month. We should have an announcement about it. And then we're going to go out and do our Series C fundraising. And we now have about 435 employees across the 3 campuses. And we're going to be building a new launch vehicle. A little bit of info about that. It used to be called Beta. Now we're just calling it Medium Launch Vehicle. If you guys saw the news, we've partnered with Northrop Grumman to replace the first stage of the Antares launch vehicle. That first stage previously had Russian engines and Ukrainian tanks. It's no longer available. There's only 2 of them left. So we're going to replace it with an Alpha, or with a Firefly built first stage that is an upscaling of the Alpha first stage. It's going to have new engines, and that's going to give us the ability to work with Northrop Grumman to deliver payload to the International Space Station. And then we're going to develop a medium launch vehicle with them that will be available in 2025. Spacecraft, the coolest thing is the Blue Ghost lunar lander. We won a contract from NASA to go to the moon. We're going to be landing there in 2024, and it's pretty amazing. You know, it's $93.3 million. And what it allows us to do is develop this technology to build a planetary lander. Once we have that technology, we're able to land on any foreign planetary body. So super exciting. It's going to give us a lot of options in the future. You look 10 years down the line, and we're going to be able to go wherever we want, land there, and then hopefully bring something back. And then we have our SUV, which is an in-space reusable space utility vehicle. And this will give us the ability to do last mile transport for satellites. It'll give us the ability to do space situational awareness, which is basically fly around and see what's out there. And then in the future, we'll be able to help to use this for orbital debris mitigation. So we can go grab something from space, drop it off into a lower orbit where it can then burn up. And then that vehicle can then go back and grab something else and come back, and it'll be in space and refuelable in space. So it should have about a 10-year lifetime. And that's it. That's the overview of Firefly. And happy to answer questions with people. Happy to have the discussion with Creon about what we've been doing. I mean, it's been I'm not going to say it's been an adventure. It's been, you know, an all-encompassing, 8.5 years to get us to this point. We've seen a lot. We've done a lot. It's pretty exciting to be back at the launch pad for the second flight. It's beyond exciting to have a mission from NASA to go to the moon, and now to be working with Northrop Grumman to deliver cargo to the International Space Station.
Great. Thanks a lot, Eric. Hey, so regarding the upcoming launch, when's it scheduled for, and what's the payload?
So it's scheduled for September 11th. The payload, we have 3 test satellites. 2 of them are from educational institutes, and 1 of them is a NASA payload. They're just small satellites. We're going to be going to a 300-kilometer orbit, which is a very low orbit. You do that because it takes all of the same steps to get to 300 kilometers as it would to get to a higher orbit. But because we're not deploying payloads that we want up there for a long time, everything that we're putting up will then just come down and burn up. So we'll be able to prove that we're able to do all, so that's first stage burn, separation of the second stage burn into an elliptical orbit. And then we're going to circularize the orbit, deploy the payloads, and then everything will then deorbit within about 90 days. And then later on this year, we have a mission for NASA called Venture Class Launch Services 2. And that is going to be to deploy, I think, 10 NASA payloads into 2 different planes. And that's going to really stress the entire performance of the Alpha vehicle. So that's exciting. And hopefully we're going to launch that before the end of the year.
Okay, so I'm going to flip over temporarily to audience questions from Steve Jurvetson, who wishes you the best. What's the cost per kilogram to LEO for the 2 rocket systems?
So the Alpha has a commercial price of $15 million for 1,000 kilograms. So that's, $15,000 a kilogram to low LEO, $24,000 a kilogram to SSO. If anybody's looking to put something into space, I can give you a really good discount right now before the first flight. As we prove that we can actually deploy stuff to orbit, then the prices are going to go up. So really, if you look at who's doing it right now, SpaceX is doing their transporter missions, and we're not competing with price against SpaceX. They're about $5,600 a kilogram or something like that for the missions that they're doing with transporter. But there's a lot of missions that can't use those transporter orbits, and those are the missions that we're going after. We're about 40 to 50% less on a dollar per kilogram basis than Virgin Orbit and Rocket Lab, which are the two primary people that have proven that they have orbital capabilities and are actually flying missions right now.
Great. Can you say anything about your second stage technology and how it differs from the first?
So the first stage engine is powered by 4 Reaver engines. Those are 45,000 pound thrust engines. The second stage engine is a Lightning engine, and that's a 17,000 pound thrust engine, but it's basically the same technology. It uses that same tap-off cycle, turbopump driven engine. It's just a smaller engine. And then the Antares stage that we're doing, that vehicle is called the Antares 330. That's going to use what we're calling a Miranda engine, and that's going to be a 250,000 pound thrust engine that is currently in development. So we're super excited about that. But again, it's going to be an upscale of the current technology that we're using. So we think we're going to be able to get that onto the test stand pretty quickly and start doing tests on that.
Interesting. Great. And the second stage is restartable, of course. And
yeah. So the second, go
what's
ahead.
What's the propellant?
Both stages use LOX RP1, so that's liquid oxygen, and rocket propellant 1. RP1 is highly refined kerosene, so these are pretty standard, well understood propellants. We're really good at working with them, and that's the same propellant that we're going to be using for the Antares 330, and it's the same propellant combination that the current Antares uses. So the launch pad upgrades to be able to get that going are going to be pretty straightforward.
Excellent. And let's talk a little bit about the lander. That's obviously a very different set of technologies. How are you on that? What's the payload, goal, et cetera?
Yeah. So that's, super exciting. If you look back at SpaceX, right, they were doing the Falcon 1. Really, what pushed SpaceX to really get big was when they got the COTS contract, right? So that gave them the ability to go out and develop the Falcon 9 and start launching the Falcon 9 with those COTS missions for NASA to be able to go deliver payload to the space station. And that turned into the commercial resupply, and that turned into taking humans to the space station. It really was the jumping off point for SpaceX. And so when the CLIPS program came out, Tom looked at it and he's like, this could be similar to, because he was at SpaceX in those days. He was one of the early SpaceX employees. He ran the test site down at McGregor and was there through that entire process of, building and launching Falcon 1, Falcon 9. And then he looked at it and he's like, this could be our version of COTS or CRS. So we chased after the CLIPS program. We got onto it. We started doing proposals. It took us 4 shots before we got one. We actually got the largest dollar award for the smaller lunar lander missions. And then at that point, we were able to turn on the hundreds of employees that we already had and all of the infrastructure that we had already built and all of the systems that we had in place. We turned that towards developing the lunar lander, and we've just been going at really good speeds. And I think just in terms of the team and the facilities and everything that we have at Firefly, we were the best positioned to actually execute on one of these programs, and it's going really well. We actually had an engine that was coming out of Ukraine that we're no longer able to use. So we had to, resource a new engine and develop our own thrusters instead of using the thrusters out of Ukraine, which, is disappointing. And that is going to delay the mission a little bit. But other than that, everything is going really well. And hopefully we'll be winning another one in the near future.
Fantastic. Yeah, it's really interesting to see the recentering of engine technology coming back to the United States with the
Yeah.
SpaceX and with Blue and with you guys.
Yeah.
It's nice to see. Um, it's a whole other topic about the disappointing globalization that was supposed to make everybody more stable and more friendly, and turns out to have had some unforeseen consequences. But that's another kind of discussion. Okay. Is there anything more you can say about other partners? Like, I know you're working with some other companies. Is there anything that can be said publicly about that?
I think, let's see. I mean, like Mike is on, we have a contract with Planet to fly in the future. You're part of Planet too. That's been publicly announced. We've announced contracts with Spire. We've announced we were working on a project with General Atomics that unfortunately NASA canceled that program. I mean, we have relationships with quite a few of the satellite companies. I think a lot of people, they said, yeah, we want to fly with you guys, go get to orbit, and then we're going to start manifesting with you. So it's pretty exciting. I mean, it really is a step function, right? There's a lot of people that say there's over 100 companies right now that are trying to build small launch vehicles. There's probably a half a dozen to 10 that actually are well along the way. Right now, there's 3 companies that have launch vehicles on the pad that haven't been to orbit yet. There's us, there's ABL and Relativity, and we're all trying to launch in September. So we actually have like a little mini space race going on to see who's going to be able to launch first in September. It's pretty exciting.
Very cool. There's been some rumors about other companies licensing your engine technology. Can you say anything about that?
I think, we have said that we have licensed our engine technology. I think if you go do some web searches, you might be able to get some
All
more
right.
information about that. But our customers on that are all pretty confidential. But it is pretty cool that not only have we developed these engines, which are all American manufactured, but they're good enough so that other people are actually buying the engines from us.
Yeah, indeed. Is there anything more you can say about the space what do you call it, the SUV?
Space utility vehicle. Yeah, I mean, what's really interesting about Firefly is the end-to-end space transportation systems, right? We consider the rockets to be the keys to space. And you're actually seeing that now with SpaceX. Like if you look at the SpaceX missions that they're doing, the majority of the missions that SpaceX are doing are for their own satellites. They're building Starlink. And if you look at, and I don't even know what the most recent SpaceX valuation is. I think it's because it just keeps going up, right? So it's like $125 billion or somewhere in that neighborhood. A lot of that valuation is predicated on the Starlink constellation. I mean, that's going to be worldwide global internet from the sky. You can already see the effect that it's having, right? Ukraine gets invaded. Elon puts a bunch of Starlink terminals onto a plane, and now they actually have internet that Russia tried to jam, and then SpaceX in like 2 days, blocked the jamming of the jamming, or unjammed the internet, and it gave them a capability that they wouldn't have had, right? So that's a way of branching out just from launch, right, into other aspects of space. So we look at launch as an enabler for everything else that we're doing. Our initial Blue Ghost lunar lander is going to launch on Falcon 9, but then in the future, when we have our medium launch vehicle, we're going to be able to launch our own lunar landers. We're able to launch our own technology demonstrators for SUV. In the future, when we're doing missions for other customers, we could launch our own SUVs, and that gives us an advantage over any of the other companies that are doing similar products, right? They have to go out and they have to buy launch from someone on the market because they're just building the SUV. We have launch that is embedded into the cost of our development of SUV, and we're able to benefit from additional mass that we might have on other missions to then go fly SUVs or go fly Blue Ghost lunar landers or do other things. And that's the magic of end-to-end space transportation, is we're just not locked into something. We're able to develop it. Those systems are cross-functional. You know, the same, eventually we would like to use the same avionics suites across rocket, SUV, and Blue Ghost.
That's great. The SUV looks a little bit like a propulsive ESPA. What are its basic envelope characteristics for mass and volume?
So we're still working on the designs of that, and it will start as a propulsive ESPA, and then in the future, it will grow to be an in-space reusable and refuelable vehicle. So we can have like SUV flying around out there, and if it runs down on fuel, another Firefly launch can drop off a fuel tank, and then the SUV can come rendezvous and then switch fuel tanks and then keep going. And so now you have something that's actually in space reusable. And in space, you know, and you know, you have to worry about the radiation environments a little bit. So you have to use rad hard components, but you're not dealing with atmosphere. So we expect that these in-space vehicles are going to be able to last 10 years and be able to do many, many missions as long as you can keep refueling them.
Fascinating. Okay, we have a question from Jonathan McDowell. Can you compare the Antares 330 to your medium LV? Are they aimed at different markets? Is the medium LV more capable than the Antares?
Yeah, the MLV will be more capable than the Antares. We're not really talking too much about the performance difference, but it's going to be able to go after different markets. Right now, Antares is only used for commercial resupply of the space station. The medium launch vehicle is going to be able to play in commercial missions for constellation replenishment. For sure, keep doing the resupply missions for the ISS. And then we're also going to be able to look at national security launch missions. I mean, it's going to be 100% US manufactured and built launch vehicle.
Are you planning to phase out the Alpha as you bring online the MLB?
No, we're going to keep Alpha going. There's different mission sets for those vehicles, right? Alpha is always going to have a space of, hey, somebody needs to fly a satellite to 900 kilometers, 92 degrees. There's no rideshare mission that's going to do that. So we're going to be able to use an Alpha to fly those dedicated missions or the smaller rideshare missions. And then we'll use the MLV for the larger constellation missions.
Okay, the last question I have in my mind before we just completely open it up is, can you say anything about any payloads that are manifested for the lander or what you think it's going to be used for? And actually that, and then I have a second question, which is, if you care to speculate, a lot of launch companies turn into satellite companies.
Yeah, so the Blue Ghost lunar lander has 10 payloads that NASA assigned to that mission when they gave us the mission. And if you go on our website, you can go take a look at them. There's some pretty cool ones. There's like I guess what we call a vacuum cleaner. It's like a little arm that is underneath the payload landing deck. And when we land, it'll drop down and then it'll vacuum up regolith, which is the lunar soil, and it'll take it into a analysis chamber, and then it'll be able to analyze the results and send those back over to Earth. There's going to be imagers. There's going to be little balls that shoot out that are going to be able to triangulate stuff. I mean, there's a bunch of cool experiments. I mean, that's one of the cool things about CLIPS is they've gone out and they've funded a bunch of these experiments, or they've gotten a bunch of these experiments. Now they're funding landers, and they're sort of marrying them together, and we can go deliver these for NASA. Everybody is going to get more experience. That this lunar economy is going to continue to grow, but in order for it to grow, you have to get people experience on doing it. And so that's the role NASA is playing right now, is helping to kickstart the commercialization of the lunar economy. And
what about are you guys going to stay out of the satellite business, or can you talk about that?
Well, the SUV is, a satellite bus that can then do hosted payloads. We're focused on the SUV right now and getting that done. We're not necessarily going after satellite constellations on our own. There's a lot of people that are doing that.
I see. And hey, I have one more and I'm sorry I took this out of order. Usually we would start with this, but I'm going to ask it nonetheless. How did you wind up doing this? This was not what you, well, this is not, I know this story to some extent, but I'll let you hear it. Like, how did you wind up giving this talk?
So Tom Marcusic, who was the founder of Firefly Space Systems and Firefly Aerospace, I actually went to college with his wife, Krista. So I've known these guys for like 30 years, and all through Tom's career at NASA and at SpaceX and at Blue Origin when he worked for Jeff Bezos, and at Virgin Galactic where he worked for Richard Branson. And I actually, way back in the day, in between the third Falcon 1 launch and the fourth Falcon 1 launch, I was down at SpaceX with Tom when he was working there. And, one of the things that really got me interested in space when I was down there, he goes, do you want to watch an engine test? And I was like, of course I want to watch an engine test. So I went out there, and it was just, they were having a hard time getting it ready to go. And finally he goes, I think we got it. Do you want to watch it from the field? And I was like, can we do that? And he goes, oh yeah, we do it all the time. I'm like, okay. So he goes, go with the guys. And he put me in the car with a couple engineers. And we went out, and we're sitting in the field, and I get out, and I'm looking at a Merlin engine, and we're like 500 feet away from it on the test stand. And I'm like, is this safe? And they go, oh yeah, we do it all the time. I'm like, okay. So they're going to do a 120-second test of this engine, and it starts up. And it's spectacular because you got like the water deluge system. Hey, there's Tom right there, actually. I'm doing crayons on, and I'm doing, sorry, I don't mean to interrupt, but yeah, there's Tom. I'm telling the story of you inviting me to SpaceX to watch an engine test, and so as we're watching this thing, you got the deluge system, huge clouds of steam are coming out, your entire body is vibrating, it explodes, shrapnel's flying all over the place. I'm like, oh geez. So we walk over, and we get like 20 yards away from where we're standing, and one of the guys is like, there's a piece of it right there. He kicks over this chunk of metal that's like this big, still smoking. I'm like, okay. And actually one of my regrets is like, I probably could have just picked it up and taken it home with me, and no one would have cared. And I would have had like a piece of an exploded Merlin engine from before they actually ever got to orbit. And I'm talking to Tom like a couple months later, and he's like, oh, we're gonna do an engine test tomorrow. I'm like, you guys gonna watch it from the field? He goes, no, that was the last one. And I was like, okay, good. But that got me excited about space. When Tom started Firefly, it's a very high risk business, low probability of success, but he was one of the few people out there that actually, it's beyond intelligence to do something like this. You have to have just a fierce determination and the ability to overcome ridiculous obstacles to get it done. And then I became one of the seed investors. I think I was investor like number 4 or number 5 in the whole thing. And eventually came to work as the IT director because I had an IT background. And when Firefly Space Systems ran out of money and shut down, it was just me and Tom that decided to keep going. We said there's something here. We could do something. We can just keep going. And my personal opinion was like, eventually somebody's going to like come and like drag us out of here and won't let us back in the building. But until that happens, we can just keep going. So we did. We got Max Polyakov from NewSphere came in. He bought up the assets, recapitalized the company, ended up putting $200 million into it. We had, the U.S. government come in and say, this guy can no longer be an owner of a rocket company because of his Ukrainian background. So he had to divest. And in the course of this whole thing, I've had, developed relationships with people that have resulted in, $170 other million of funding coming into the company. I mean, we've raised a lot of money at Firefly. And
speaking of which, how's your runway, and like, how solid are you guys?
Yeah, I mean, we're super solid right now. We had the industrial partners are the people that came in and bought Max's equity from the company, and they did a Series B for $75 million. So that's given us, pretty good runway right now. We're going to, have to go out there now and do a Series C here pretty soon, hopefully on the back end of a successful rocket launch, which is going to make it better. But even without that, we have contract from NASA to go to the moon that's worth $100 million. We have a deal with Northrop Grumman to go to the International Space Station, and we're going to develop a medium launch vehicle with them. And that was not something that happened overnight. We've been working on that for a year, and different aspects of that deal for a year. And I think Northrop Grumman coming in and looking around the landscape of who's out there and making a decision about who they want to work with to go do that, that's a pretty big stamp of approval on who they think is capable of doing something like this. And Firefly is one of the few companies that is capable of doing it. So pretty exciting.
How does how do your rockets stack up against the Neutron?
So the Neutron is going to be the bigger Rocket Lab vehicle, and it's going to be somewhere in the class of the MLV. So that'll be a competing vehicle for MLV. I mean, I honestly think that because of the way that we've developed Alpha is about 4 times the payload capacity of Electron, which is the first vehicle that Rocket Lab did. We're able to upscale all of our technology. And there's going to be some significant redevelopment that they have to do. I'm not saying they're not going to do it. I know the guys, they're really smart guys, but we're able to upscale the Reaver engine into the Miranda engine using the same tap-off cycle, bigger turbo pump, but basically, we understand the problem. So they had an electric turbo pump before, and now they're going to have to go and develop different technology. They can do it. I mean, they have an amazing team, and they have a lot of money, and they can go out and do it. But I think we're actually in a really good position to go out and work with.
Why are you guys going for bigger engines as opposed to the SpaceX approach of just putting more engines?
Well, we are going to put more engines. We're going to have 7 of the Miranda engines, but you can't. I mean, we don't want to have like 20 or 25 or whatever of the Reaver engines. They're just not big enough. I mean, you're going from 45,000 pound thrust engines to 250,000 pound engines. You need the bigger engines to do that MLV.
All right. Well, I've kind of run out of questions here. If anyone wants to, okay, we have one more from the audience, and then we can take people can just unmute if they wish to. Someone asked a question about do you buy pre-woven carbon fiber, or do you weave and epoxy single fibers directly onto the mold structure? Or just, I know you couldn't show us a video, but there are videos online of these automatic carbon fiber weaving machines. Maybe just they're not like yours, but they use them for cars and stuff like that, right?
Yeah.
Talk a little bit about that composite technology and what your edge is.
Yeah, so they use the AFP to do all the big wing, to do big wing structures, right? So that's billions of dollars that the aircraft industry put in, the Boeings and the Airbuses, to be able to develop that technology. And we're just able to go out and buy the machine that does it. Currently, we use the hand layup methodology, and we do use pre-preg, right? So the carbon fiber comes in big sheets. You have computer programs that cut it up. You put it onto the tools. We use an out of autoclave process. So we put the tools with the pre-preg on top of it into the ovens, and it sort of bakes them. And then we get them out, and you get the finished product off of the tools. We'll use a pre-preg with the AFP machine too. It'll be different because now it's like feeding in through, these things are called toes, and I don't really know the whole process, but instead of sheets, it's going to be like streams, and this thing moves fast. So it lays down a ton of material per hour, as opposed to the hand layup methodology, which is people use lasers to line up where they put the next sheet, and they have to smooth it down, and then you have to do multiple different processes in order to finish it. So that's where you go from 3 months to do all the structures for an alpha to 3.5 days, which is pretty significant. You raise the quality, you actually have to use less material. So you're going to increase your performance to orbit because the same rocket is going to weigh less. So when you take the weight away from the rocket, then you have the same engines and the same thrust. That means that you're able to put more payload into orbit.
Right. Yeah. Okay. So, I actually can ask more questions, but if anyone wants to unmute and ask their own questions.
Patrick has hand raised.
Oh, okay. Patrick. Sure.
Hey, can you guys hear me?
Yep.
Sorry, just got a phone call just as I did a turbo. Yeah, this is kind of a bit on a different topic, but curious how you're thinking about growing and finding talent as you guys kind of scale up and build your second vehicle. I know it's like really hard to find GNC or like software controls talent, people like that. I know you guys have a really cool partnership with Trell at UC Austin, but would love to hear your thoughts on this.
Yeah, so I mean, that's a great question because right now it's super competitive to find good talent in the aerospace industry and the rocket industry. I mean, you look at the number of people that are working at SpaceX, the number of people that are working at Blue, the hiring sprees that Relativity and ABL have gone on recently. You have Stoke coming on and sucking people up. We do have at UT Austin, there's this Texas rocket engineering lab, Trell, and we have a nonprofit called Firefly Academy. So we help fund that, and we have a great internship program. I think this year, I'm not sure how many we had, but last year we had about 60 interns that came through the program. And that by itself gives you a pool of people that you can go hire from. And then we're doing nationwide recruiting, and I think as we get to orbit this next time, and with the news of this Northrop partnership to go to the ISS, it gets people excited, but it's a battle out there for talent. And especially we're competing against, the triangle of companies that are out in California where people can bounce back and forth to those companies. They don't have to move. They can just keep working out there. We actually have to pull people to Austin. The other thing that we're seeing is Austin is starting to become an aerospace hub, and that's what we're hoping for, right? Because you need multiple aerospace companies in an area to make it more attractive for people to move here. Because if they come work for Firefly and they don't like it, they can go work for Cesium Astro. Or if they go work for Cesium and they don't like it, they can come work for Firefly. And actually, the CEO of Cesium was an ex-Firefly guy, right? Ex-Lockheed guy, but he was at Firefly Space Systems. And then when we shut down, he went out and he started his own company, and they're actually doing really well. So you incubate talent, and we've had multiple startups come out of people that worked with Firefly.
Great. Allison, you got your hand up.
I have my kind of like eternal question, which is I would love for you to foreshadow a little bit where you can see this going in 5 to 10 years, and like whether or not you're optimistic, and paint us a little bit the picture of like what's going to be enabled by your technology in maybe combination even with others. Like what's like a thing that people can get excited about.
Yeah, I mean, I'm super optimistic about space. I mean, this is the very beginning of like the future space industry. You can start seeing it like SpaceX, I think, is doing a rocket launch a week now with Falcon 9. They have Starship that's on the pad that they're going to be launching soon. We're going to do the medium launch vehicle. These CLIPS missions and these lunar lander missions are going to get bigger and bigger. And we're going to actually start having a sustained presence on the moon. And we're going to have commercial LEO destinations that people are going to go to. And people are going to be able to right now it costs what, $20 million-ish or something like that. I don't know what the current cost is to go stay on the space station, but I think if you look forward 10 years, Axiom is building their own space station. Other people are building their own space stations. You're going to start bringing that level of economic investment down for people to actually go out and do these things. It's not going to be cheap anytime soon, but I can see, maybe not for me, but I think for some of the people on this line in the future, if you're pretty successfully financially, you could potentially go spend a weekend in space, or a little farther in the future, spend a weekend on the moon. And I think that's super exciting.
Well, look,
mean,
you guys are going to the moon and building rockets to go all over the place and building space tugs. Are you also going to build a human rated system or left for
I mean,
someone else?
that's not in the plan right now, but I will say that when I did my employment contract for Firefly, I wrote into my employment contract that if we ever do human space flight, that I get to be the first person that goes. So
Okay,
we'll see. You know,
that's definitely dog fooding.
Yeah.
All right. And so channeling my inner Allison now, I would have to ask, what do you need? What are you looking for? How can people in this group help you realize your vision?
Yeah, I mean, I think if you need satellites that have to get on orbit, reach out to me. That's my job. I'm the commercial business development director. So I work with our customers to get them manifested on Firefly missions. If you have something that you want to take to the moon, let me know. We're going to hopefully be winning another NASA mission. We're going to be doing our Series C. So if you have an interest in investing in what I think is the best new space transportation company out there, reach out to me. I'll connect you with our financing people and we'll get you guys involved in the Series C.
And if we know any aerospace talent that wants to
Oh,
move to Austin,
yeah. Hot aerospace talent, connect them with me and I'll put them into the process.
All righty. Well, last call for questions before we close up here. Just want to mention we have a very exciting roster of upcoming speakers.
Luke as well.
Oh, Luke's got a question. Go, Luke.
Eric, thanks so much for joining us today. We really appreciate the talk. It was really enlightening. When I think of Firefly, I think of this company that's so inspiring because you just absolutely refuse to quit. You just like keep going. And as a executive of a hard tech company that does a lot of stuff with hardware, like I would love to hear what advice you would have given yourself 10 years ago before you jumped on the Firefly train that would have like made a difference in terms of sales and just making the company actually work and landing some of the contracts that you did.
So there's a couple things, I appreciate that. And it was actually super fun to be here and thanks. And persistence when you're doing hard tech, when you're doing something like this is critical. We had a lot of people that were with us that just gave up and it was too hard. And if you've ever, Creon's been here, if you've ever been to our offices in Cedar Park, we have an office space that, there's probably room for 150 people in. And when we shut down the first time, we had 160 people working for the company. We restarted, brought about 70 people back, shut it back down again. There was a period of time when me and Tom were the only two people that were in this office. And we would come in here every day and try and figure out what the next step was. And I'm not a rocket guy. So like I was just there for moral support. For the most part, it was like, hey, we're just going to keep going. And we did, so is there a guarantee that that's going to help you make it? No, but you can't do something like this if you're going to give up when it looks really bleak, because it does look really bleak most of the time. I mean, there's no way around it. It's just hard. And the other thing I would say is when we started the first Firefly space systems, we were like, oh, we could bootstrap it and then we can go out and raise more money. It's really hard to raise money for this stuff. You should have good financial partners. If you're going to undertake something like this, you have to have people that are excited about your mission. You have to have people that are going to stick through you. I would say stick with you. I would say the hardest part about doing this entire time has been the financing aspect of it. We've raised over $350 million for this iteration of Firefly. We raised $30 million for the first iteration. It's a very long-term investment for people. So you need to have people that believe in your mission, that are going to stick with you, that are going to help you go out and find other people that are going to be there with you. It's very important who you're working with. It's important who your investors are. you know, we've learned a lot of lessons about that along the way. And then you have to have people on your team that are excited about doing it, because just like it's hard to go out and raise the money, it's hard to do this. You know, it burns out a lot of people. I mean, these stories that you hear about SpaceX and the number of people that burned out at SpaceX, it's true. You know, you're trying to do a lot, and you're trying to conserve your capital, and you're trying to just continually stretch out the runway so that you can get to the next milestone. And the people that are with you that are doing it, it takes a toll on them, you know, to be able to do it. So you have to respect that, and you have to do everything that you can to protect and help those people, because when people burn out and you lose them, it's hard to replace them. You know, you don't want that to happen. So what are you going to do to try and take care of the people that are around you?
Great questions. Okay. Well, I guess we'll end on that high note, that note of inspiration and perseverance and fun. And Eric, it's been great getting to know you. I'll see you soon in Austin.
Yep.
And
And
thanks for coming to the Foresight Space Group. Feel free to suggest other speakers or audience members. And we'll see you next time. Thanks, Allison.
thanks everyone. It was great being here. Loved getting a chance to share the time with you all.